9. I was just wondering what it means, like what it's asking for.
And 29. This is
Mhm.
the triangle problem.
Oh, okay.
So if you're dealing with the triangle, remember you're doing arcsine. Well, arcsecant. Secant goes with cosine. Cosine is usually adjacent over hypotenuse. So then you would have hypotenuse over adjacent. And then you're going to do your Pythagorean theorem, call this y. And then solve for y. So we can put that there. And then you're doing cosecant. Cosecant goes with sine. Sine's usually opposite over hypotenuse. So this time we would have hypotenuse over the opposite.
Okay. Thanks.
What other problems do you have? Marissa, do you have any?
Yeah, can we look at 7?
Okay, on this one, you're gonna have to do implicit. So what's the derivative of sine?
Cosine.
Cosine, so you'd say the cosine of xy times you gotta do the derivative of the inside, and in that case, you have to do product rule. So first times the derivative of the second plus the second times the derivative of the first, which would just be 1, is equal to, and you got to take the derivative of the other side, which would be 2x. Now what you have to do is kind of just, we can divide both sides by the cosine of xy. So we would have x times y prime plus y equals 2x over the cosine of xy. Now you're trying to solve for y prime, so we're going to subtract y. And then divide everything by x, because we're left with x times y prime. So when you do that, you get 2x over x cosine of xy. And if we want to do, we have a minus y, but then don't really want that there. We have to divide it by x, but you have to get a common denominator. So in order to get a common denominator, I need the cosine of xy over here. But if I put it on the bottom, I have to put it on the top. So I'd have x cosine of xy on the bottom and 2x minus y cosine of xy on the top. Now, that doesn't match any of our answers. Notice all our answers have secant, and none of them have a trig function on the bottom. What could we do to get rid of that cosine of xy on the bottom?
One over cosine xy.
Correct. Times 1 over the cosine of xy on the top and on the bottom. So then that's going to go away and leaves us just with an x in the bottom. But we'd have 2x over the cosine of xy minus y. Oops, I don't want that. All over x. Now, if you have 1 over cosine, what is that the same as?
Secant.
Secant. So then that is really e, because it's 2x secant of xy minus y all over x. So what you'll have to think about is, the reason why I was given the multiple choice was so that those that are taking the AP test would see that. So as far as the simplification part on your test, you won't have to do that. If you get it to the point where you're solved for the derivative, then that's all I need. As long as what you have done is correct, I'm not going to take off for simplification. Other questions? Go ahead.
Yeah, can we go over the process of 9?
Of 9. Okay, so
Yeah.
really with the derivative of the inverse, you need to know the formula. And the formula is 1 over the derivative, oops, of the inverse function. So on this one, they give you the function. So we need to find two things. We need to find the derivative of it, and we need to find the inverse of it. So what is the derivative of that function?
Negative 1/3 x to the negative 4/3.
To the negative 4/3. That's correct. So if we find inverse, remember you switch your x and y, and then you solve for y. So you're taking both sides to the negative 3rd power. Then these cancel, and that is my inverse. So to the negative 3rd. So now this is really a composition. So we're saying 1 over the derivative evaluated at the inverse. So we're going to do a negative 1/3. Instead of x, I'm replacing it with the inverse. And then to the negative 4/3 power. So if you look here, you have a negative 3 times negative 4/3, which really gives you just to the 4th. So this is equivalent to 1 over negative 1/3 x to the 4th. Now, if I have a fraction, so I can multiply that and get that to be a negative 3rd. If I want to bring x to the 4th up, it would be x to the negative 4th, which gives you e. But really what you need to know for something like this is that. So think back to the quiz that we did too. It was a little bit different because I actually gave you a function and I gave you a point. So what was the process we had to do there?
I graphed it and then found the other point of it.
Right. You graph it and you plug in your function, your original function that's given, and you plug in the x value that they gave you. And you're trying to find really, that's a y value. You're trying to figure out what x value is going to give you that y value. And then you plug it into your equation.
So first you find the derivative of the function,
Uh-huh.
and then how do you find the inverse again? That's where I got tripped up.
Find the inverse, you switch x and y and solve for a y.
So it would be y to the negative 1/3 equals
Yeah, I said
just x.
Y to the negative 1/3. Then I took both sides to the reciprocal power, which makes these cancel out. So I get x to the negative 3rd.
Oh, okay.
Other questions?
Yeah, can we go over 17? Because I don't know what to do when it's squared.
Okay, so think of this and rewrite it as arc tangent of 5x to the 2nd. So you got to do chain rule. So chain rule says I'm going to move the 2 out front. I'm going to leave the inside exactly the same. Subtract 1 from my exponent times the derivative of the inside. So what is the derivative of arc tangent?
Is it secant again?
No.
U prime over 1 plus u squared.
So what would your u be in this case?
5x.
So on the bottom, we're going to have 1 plus, it would be 5x squared. Make sure you put parentheses around that. And then the derivative of that u is going to be in the top, which would just be
5.
5. And that's your answer.
Oh, okay.
Can we do 12?
How did you get the 1 plus 5x squared?
That's the formula right here for arctan. That's one of those ones in the front of the book.
Oh,
Just make sure you're looking at the right ones. So if it's asking for derivative, make sure you're looking at the ones at the top. If it's asking for integration, make sure you're looking at the ones at the bottom. You said 12?
Yeah.
Okay, so what you want to look at here is, if you look here, we have the function in the bottom and the derivative on the top. What integral gives you, or when you're taking a derivative, I guess, which derivative gives you the function in the bottom and the derivative on the top?
ln.
ln. So if you're integrating, then if you want to think about it in terms of u, your u is usually the bottom. Well, the derivative of that is already the top. So you would have the ln of f of t. You're going to evaluate that between a and b. And then you're going to set that equal to what they're saying is the ln of f of b. Now, if you're evaluating the ln of f of t from a to b, you would have the ln of f of b minus the ln of f of a equals the ln of f of b. Now, with subtraction with logs, what can you do? Divide. So you'd have the ln of f of b over f of a equals the ln of f of b. Now, because you have an ln on both sides, you can really say that this is the f of b over the f of a equals the f of b. So you're solving for f of a is what they want to know. So you can multiply both sides by f of a and divide by the f of b. So then what happens is these cancel. You end up with the f of b over the f of b is equal to f of a. So f of a then is 1. Other questions?
Is the test going to be multiple choice as well?
No.
We get to use the front cover of our book though, right?
Yeah. Other ones you'd like to see?
Oh, on the test, for the Hospitals rule, are we gonna have to show that it's like equal to infinity or 0 or
Yeah, you
one of
need
those?
to be able to show or tell me what indeterminate form it is.
Okay.
Is it 0 over 0 or infinity over infinity or what one it usually is?
How long is the first section of the test going to be, and how long is the second section of the test going to be?
I printed it all off, but I'm not sure the division part of it. You should have plenty of time. Other questions you want to see on the review?
I would like to see 13. I keep getting it wrong every time I try to do it.
All right.
Also, are the answers to the review posted?
Yeah. So did you
On
do?
Canvas?
Yeah. I actually did it all on Friday and then I left it at school and then I felt bad, so I redid it all today. So if you used u to be your x squared plus 16, your du would be 2x dx. Well, really you just have x dx. So we need to have a 1/2 du. Is that what you had, Marissa?
Well, whenever I did it, I originally made my u the square root of x squared plus 16. So that's what I did wrong.
Okay. You want to keep going through it?
Yeah, because now I'm confused.
Okay, so then we would have 1/2 and we'd have really 1 over u or the square root of u. and then du. So if you pull your 1/2 out front, you're integrating, it's really u to the negative 1/2. So if you raise that exponent, you would have u to the 1/2. But I need to multiply or take my 1 divided by a 1/2, which is going to give me a 2, but I have a 1/2 already there. So those are going to cancel. So I really get u to the 1/2 plus c. And well, I don't need plus c because I'm evaluating it. So u to the 1/2. And I'm evaluating between 0 and 3. So I'd have the square root of x squared plus 4 or 16 from 0 to 3. If you plug in 3, that gives you 5. If you plug in 0, that gives you 4. So 5 minus 4 gives me my 1. Is that better?
Yeah.
Other ones you'd like to see?
Will we have time to work on this tomorrow too, or are we doing something else?
I planned on doing like board work tomorrow, just practice problems on the whiteboards.
Can we do 14?
14. So really what 14 is asking for is the second derivative. So if we take the derivative of ln, remember it's the function on the bottom. Oops. And the derivative on the top. The derivative of 3x plus 5 is just 3. So then we want the second derivative. So what I would do with that is I would go ahead and move this to the top. If I take the derivative, then I'd have -3, leave the inside alone, raise it to the -2 times the derivative of the inside, which that's going to give you a -9 over 3x plus 5 to the second power, which is t.
Okay, thank you.
Anything else that you want to see?
Sometimes it's just hard to tell what it's saying.
So really what you're gonna have on your test, you're gonna have a big section like this that's gonna ask you to find derivatives. You're gonna have another big section that's gonna ask you to integrate. You will have to find a tangent line. We've had quite a few of those on the homework questions. And then you'll have some L'Hopital's rule.
Can we do one with the tangent line?
You wanna do the tangent line one?
Yes.
So it says find the tangent line to this at the point where x equals 2. Well, the first thing I would do with this, since it's an ln, I'm going to actually I'm going to expand it out. So it would be the ln of 3 plus the ln of e to the 5x minus 10 minus the ln of 7. Now, what happens with ln of e? What is that equivalent to?
1.
Yeah, so you're just really left with 5x minus 10. Now, we got to find the derivative yet. Well, what is the derivative of ln of 3?
1/3.
Well, ln of 3 is just a number.
It's just 3, right?
1/3.
It's just going to be 0 because ln of 3 is a constant.
Oh.
Okay,
Oh,
so that's a constant. What's the derivative of 5x?
5.
5. Derivative of -10 is a constant, so that's 0. Derivative of negative ln of 7 is also a constant, so it's 0. So the derivative, no matter what x value I put in, is always going to be 5. Now it gives you the x value, but it doesn't give you the y value. So you actually have to put this 2 into here to find the y value. If you plug 2 in there, you get 5 times 2, which is 10. 10 minus 10 is 0. e to the 0 is what?
1.
1. So then it's just 3/7. Now, if you plug in 2, your slope is going to be 5 because it doesn't matter what x value you have, it's going to be 5. So when you find your equation, you would have 3/7, which is your y value, equals your slope, which is 5, times your x value of 2 plus b. Whoops, it should be the ln of 3/7, not just 3/7. So when you solve for b, you would have the ln of 3/7 minus 10. So it doesn't come out very pretty, but your equation then would be y equals 5x plus the ln of 3/7 minus 10. And that's all you can really do with that. Write that a little bigger. So just remember when you're doing tangent line, go ahead,
Why is it ln of 3/7?
because there's an ln right here in front.
Oh, yeah.
So remember with tangent line, your first thing is find your derivative. Find your slope, and you're finding your slope by plugging in the x value. And then find b, and then write it as y equals mx plus b. Other questions? Just to kind of give
Can we
you
do 8?
what?
Can we do 8?
This is actually very similar to the one that we did with the f of t thing. So when you're doing this, just worry about what's right here. So if you were integrating 1 over x plus 2, what would it be? So if we think of it as 1 over x plus 2 dx, so that was our problem. If you
The
want
ln of x plus 2?
the ln of x plus 2. So you really would have ln of x plus 2. You're evaluating that between k and 6. So you're really just plugging it in. So if you plug in 6, you would have ln of 8 minus the ln of k plus 2. And they're saying that's equal to the ln of k. Again, when we have ln, when we have logs, when we have subtraction, we can change them to what?
Division.
Division. So it'd be ln of 8 over k plus 2 equals the ln of k. The ln's we can cancel out, and we're solving this problem. Well, really what you're ending up solving would be something that looks like this. So it's a quadratic. So we have k squared plus 2k. We can move that 8 over and say it's a minus 8. Make this a 0. So then you're factoring it. How would it factor?
Positive
minus-
4, negative 2, so k plus 4 and then k minus 2.
So then k would either be a negative 4 or k would be a positive 2. Now, but remember, you can't take the ln of a negative number, and this says ln of k, so your only answer can be 2. Other questions?
What is 29?
29?
Yeah.
29 is the one where you have to draw the triangle. You did that one, I think, before you got on here. So remember when you draw the triangle, you start with the inside, and this is like x over 1. But it's arc secant, and secant goes with cosine. So if we think of cosine, cosine is adjacent over hypotenuse. So secant would be hypotenuse over adjacent. So that's why I put my x on my hypotenuse, my y here. Then I would do my Pythagorean theorem to find the other side. Then I go to my outside function, which is secant. And secant goes with our sine, which is opposite over hypotenuse. Well, secant then would be hypotenuse over the opposite. So it's x over the square root of x squared minus 1. And you'll
Where
have
did you-
one. What?
Where did you get the x squared minus 1?
We had to do Pythagorean theorem over here
Oh,
because we would call this y and then set up 1 squared plus y squared equals x squared. But you will have one on your test where you're going to have to do that kind of thing with the triangles. Anybody have problems on the integration ones? Or just haven't got there yet?
I haven't gotten there yet.
So let's look at 32. What are you gonna have to do to be able to solve 32?
Split it. Or no, actually, no. Could you
Divide.
just
You'll have to
You're gonna have
divide
to
the
divide it.
top by the bottom.
Yep. You would have to do your division. Now, since this is linear, you can do synthetic. You would do 1, 0, -5, and 7. So similar to what we did before. So you're really integrating. If you're dividing out 1x, that's going to leave you with x squared plus 2x minus 1 plus 5 over x minus 2 dx. And then you're integrating each piece. Just remember that if your exponent on the top is higher than the one on the bottom, you have to do that division. What about 33? How would you go about 33?
bring it up top?
You can't, it won't work.
And then quotient rule?
It's integrating.
I
So
don't know.
would you have to
What?
do u?
eventually you have to do u, but there's a strategy that you're gonna have to do or a technique you'd have to do before that. You're gonna have to complete the square with the bottom. So if you think.
How do we know to do that?
Because if you would have brought it up like you were wanting to do, you would have had something like this. -1/2 times 2. Now, we don't have anything close to the derivative of the inside on the outside because the derivative of the inside would have been this. And I don't have anything close to that. So that won't work. So the only other things that we have, if we can't do it like that, would be an ln, which that doesn't fit either, or one of the inverse trig functions. And if it gets down to the inverse trig functions, remember it was always like a squared minus u squared or u squared plus a squared. Does that make sense? So you have to, that's the only other approach we have to be able to do it. So that's kind of how I would look at it. So the first thing that you suggested would have been the first thing I would have tried. Put it to the exponent, move it to the top. Well, if that isn't going to work, then the next thing I would look at, is it an ln? Would an ln work? Well, if that's not going to work, then it's going to be one of the inverse trig functions. So that's kind of where your process of thinking should go. And if it's an inverse trig function, this part that's under the square root has to be in that right form. And this one is not. So remember, we had to take that -1 out. So we'd have x squared minus 6x. And then we put our plus 2 at the outside. How do we get our number that we're going to add? How do we complete the square?
You take your 6 divided by 2 and then square it.
So -6 divided by 2 and square it, which is going to give me 9. But if I add 9, what do I need to do on the outside?
Subtract 9.
Normally it would be subtract, but we've got that -1 in the front, so we're not really adding 9, we're actually subtracting 9. So we actually have to add it here because of this -1 in the front. So it's not always that way. So if we are integrating, then we would have 2 over the square root, and then I would have 11 and then minus, factor out what's in there. So it would be x minus 3 squared dx. Now, which one of your trig functions does that, or inverse trig functions does that look like?
U over,
Arc.
right?
Arc which one? Arc sine, arc tan.
Is it arc sine?
Yes, it's arc sine. So if it's arc sine, what would it look like? So it'd be 2 times the arc sine of what?
It'd be arc sine, a square root of wait.
It's u over a, isn't it?
Yeah, so it'd be x minus 3 over square root of 11.
And then what do we
Plus
need at
C.
the end? Plus c. So really it's getting into that form where it fits. Make sure if you see anything like this, where it's a number raised to a power, that you're looking at the front cover of your book.
Why?
Because those are all in there. Those are the ones that are integrating a to the u.
Oh,
Similar to 38, it's a to the u power. What would we have to do for 37? What do you think?
I'd say bring it up top again, but
You can try that. So we'd have x squared, I'm going to rewrite it, x squared plus 4 to the -1 times x plus 3. The problem with that is if you are at a -1 power and you add 1 to it, where are you at?
0.
0. So that usually means that you're going to end up doing some kind of a natural log when that happens. However, since we have 2 separate things on the top, we're going to have to do something before that. What do we have to do with that fraction?
What fraction? Oh, that whole thing. Oh,
We can break it apart. Now, if we think about our first piece, so if we just look at this piece, we can let our u be our 4 plus x squared. Our du would be what?
2x.
2x dx. Now, that's close. We have an x dx, so we're going to have to divide by a 2. So we'd be integrating, you put the 1/2 out front, 1 over u du, which is really what?
ln.
The natural log of u. So we would have the ln, we have 1/2 times the ln of 4 plus x squared plus, now we need to integrate this piece. Now this piece, it doesn't have an x in the top, so the ln won't work. We can't bring it to the top because when we add 1, we get a 0. So it isn't a power 1. It's not an ln. So what do we have left? We have one of our inverse trig functions.
In the book.
Yep. So which one of the inverse trig functions would this look like?
Is it secant?
I don't think this one's secant.
This sine or one of them?
It's not sine because sine has a square root on it. Secant also
Is it
has-
arctan?
It's arctan. So we're gonna have 3, but then it's times 1 over a. What would our a value be?
2.
2, so it's 1 over 2. Arctan. Then it's u over a. What would our u be?
X.
So it would be x over
2.
2. And then we need what?
Plus C.
Plus c. And that whole thing would be our answer. So if you see a fraction like that with the 2 pieces on the top, you can split it apart. And a lot of times that will help you find, and you can do each piece individually. Any other ones you'd like to see? Or talk about?
36 maybe.
36 is one kind of like what you had on your quiz.
Yeah, that.
Yeah,
it
we
was
already
really
had that.
Yeah. So what is your u on that one?
It's just ln of x, right?
Yep, ln of x. du is
1 over x.
1 over x dx, which you have that there. So this is really the integral of 1 over u du, which is really the ln of u plus c, which is the ln of x plus c.
Okay, I wanted to make sure I was just doing it right.
Yep.
I would like to look at 31.
Okay, if you're looking at 31, what do you think? Where do you think you could start?
With that square root.
Okay, what would you do?
Make it a 1/2.
Okay, so I'm going to rewrite this as the ln of x to the 1/2 power times 1 over x dx. Does that help you figure out what you would need to do?
Yeah.
What would you do then?
You would make your u the ln of x.
And your du then is your 1 over x dx, which is already,
Yeah.
so then you're really integrating u to the 1/2 du, which would be u to the what power?
The 3/2 power,
And your coefficient would be
2/3.
2/3 plus c, and then plug it back in. So it'd be 2/3 ln to the 3/2, or ln of x to the 3/2 plus c. What would you do for 30?
Cry.
Cry? Not too bad.
Yes, cry.
Wouldn't you make your u the cotangent of x?
U would be the cotangent of x. So what is your du? What is the derivative of cotangent? And if you don't know it, you can use the front cover.
Negative cosecant squared.
Of x. Now that you have to realize that's negative 1 over sine squared of x. Which actually you have 1 over sine squared of x. So we only need to get rid of the negative. So negative du equals 1 over sine squared x dx. So if you're integrating this, it would be, we can put the negative out front. It would be e to the u du. And then integral of e to the u is still e to the u. And so then just plug it in. So you'd have negative e to the cotangent of x plus c. So anytime you see an E, usually your U that you're gonna want is your exponent of the E. Anything else you want to see or talk about? We've done quite a few of them. So on here is none of the L'Hopital's rules, so you need to make sure that you're looking at some of those. Looking at question 25 here, what would you need to start on 25?
Will you let us have the equations for arctangent or arc?
You'll
Like-
get to use that front cover of your book. It has all of them on it.
Oh, okay.
On 25, would you make both sides like of ln?
Yeah, you're gonna take the ln of both sides. So anytime you see something that's really complicated like that, that's what you're gonna usually do, is you're gonna take the ln of both sides. So that, or you can think of that as ln of y, it's probably easier. And so what does taking the ln allow you to do?
Break it apart.
Break it apart and then take the derivative of each piece individually. So another problem, I think there was another one like that, like 20 is the same kind of thing. Take the ln of both sides. You don't have to do that on 23 because the ln is already there. You do have to do that on 19 because you have a x in the exponent and an x in the as the base.
So it would be ln of y equals ln of x to the negative 2x.
And then what does that allow you to do with the exponent?
Make it negative 2x.
Bring it
ln of
forward.
x.
Yeah, bring it forward, negative 2x and then ln of x. Now you're just going to do product rule on that side. On the other side though, ln of y is going to be y prime over y. And then you're going to have to do product rules. So first times the derivative of the second plus the second times the derivative of the first. And then you're going to have to solve for y prime. So when you multiply both sides by that y, if I simplify this a little bit, and I multiply by y, what's the last step that I have to do here?
You have to plug in x to the negative 2x for your y.
Right, so our answer would be x to the negative 2x, and then negative 2 minus 2 ln of x. So don't forget, some people were forgetting to plug in the y. They would do everything right, but they wouldn't plug the y back in at the end. Anything else that you want to go over? All right, like I said, I did post this answers to all of this. It's in Canvas. It's under the chapter 5 review.
Thank you for going over this stuff with us on Sunday.
It's all right. My neighbors, when we went for a walk, told me I was crazy. Both of them are teachers, but. All right, well, I will see you guys tomorrow. And like I said, we're going to do board problems tomorrow just to keep practicing.
Okay, thank you, Ms. Gilliland.
You're welcome.
All right,
Have a good
thank
night.
you.
Bye.
You too.
Bye.